And so let me close my microphone so you know what to do. If you want to ask me questions, you can ask me through Zoom. But the video is listed this time, so we can access it through your channel. Could you? Do you access to the video? Yes, I see that people are joining actually. Okay, I think you are joining, so it means that it is working, because last time I didn't publish it as public video, but I don't think there's a problem. We can just publish it publicly.
Have you published the live stream?
Yeah, in principle, you should be able to see that one as well, but you need to turn your speaker off if you want to see it from there. There's no point.
I already.
Okay. So here we are 26. I expect there should be 26 people there as well. 16. So I need to wait a little bit more for everyone to join.
De har lite sikt.
Det ser
allting någon sekund för. Helt crazy. Helt crazy.
Men inte.
Let me see what is the
picture there. There's a bit of latency. Yeah.
But anyway, you could find it. Others should also be able to
I
find it.
couldn't find it on your channel. It didn't pop up for me, but I used the link and it worked.
Okay.
Maybe it's unlisted.
No, this is public.
It's public. Okay.
Yeah. Might be the YouTube channel of a school is not that popular these days. I don't know.
Really?
Yeah. Okay. So should I start or not?
I think
Because I see that 28 are in Zoom, but when I go to YouTube, I see only 22.
I mean, there's a bit of latency, so I mean, everyone might be in anyway.
So let us start, because I want to give you time to practice on yourself again. So I will start talking about. Oops. Now this is getting. Yeah. Okay. So let me just close my microphone. If you want to talk to me, just talk to me through Zoom. Okay. And I can also turn off my camera here. We don't need the camera on Zoom. Okay, so we want to talk about another very important topic, which is included in the geometry part in your book, and that is called the vectors. Okay, so first we want to know what is the meaning of a vector. There are some quantities that we can just know about them just by knowing the number. For example, if I want to talk about the temperature, I can just give you the temperature of today as a number. For example, I can say that the temperature today is 10 centigrades. Yes, but some quantities, it's not clear just by giving you a number. You need to also give me a direction. Okay, so for example, displacement is a quantity which is not completely clear by just giving me a number. For example, if you tell me just displace from the place that you are standing one step, I can take this step in this direction and I end up here. I can take this step in this direction and I will end up here. And the results are different. Yes, so displacement has two properties: a number here in this case, one step, for example, 50 centimeters or whatever, and a direction. So these quantities of these types are called vector quantities. Yes. So vector quantity is a quantity that not only needs a number to be specified, but also needs a direction to be specified. Yes. So can you, for example, give me another example of a vector quantity? Yeah, you can participate, and anyone in the
like if you shoot the football, like it'll go to a certain direction. I mean, if it goes.
No, name the quantity. For example, here I name the quantity called displacement. Displacement is a vector quantity. But on the other hand, distance is not a vector quantity. Yes, that's just a number. If I want to give you the distance between 2 points, I can just give you the number. I don't need to give you the direction. But if I want to say displace from your position 1 meter, you might ask me, okay, in which direction should I move 1 meter? Okay, so it means that if I just tell you move 1 meter, it's not that clear exactly. I need to tell you the number. I also need to give you the direction. Now, so displacement is a vector quantity. Distance is not a vector quantity. It's called, if you want to know the name, it's called the scalar quantity. Yes, so we have scalar quantities. And we have vector quantity. Okay, a scalar quantity are those quantities that can be specified by just giving you a number. Vector quantity is a quantity that it is not clear exactly, cannot be specified exactly with just one piece of information, the magnitude, the size of that. I should also give you another piece of information regarding the direction of that quantity. Okay, so if I want to give it some quantities here, so I mentioned one of them here, that was the distance between 2 points. Yes, and then here I wrote displacement. But now, for example, let us start with this one because this is a little bit simpler. Can you give another quantity that it is a scalar quantity? Just a number is enough to show it.
Like area?
Speed.
A speed, yes, but a speed is a little bit problematic. There is a difference in this English word between a speed and velocity. I know that there is also a difference here. I think one of them is called fart, the other one is called hastighet or something like that, because I saw the physics books, they distinguish between these two words. So if you don't mind, let us avoid the speed, but you are right. A speed is a scalar quantity, and that is exactly shown by the speedometer on your car. The speedometer on your car doesn't care in which direction you are moving. It only cares about the magnitude of your speed. Yes? So that speed, you are right, completely right. So a speed is a scalar quantity. In contrary, velocity is a vector quantity. But let us avoid that, okay? Another example, anyone? Of a scalar quantity. There are many, many quantities. For example, if you want to go buy bananas by kilogram, you just take it. So for example, it's also problematic. Yeah.
Could it be time?
Yes, time, for example, yes. Time is a scalar quantity. So I can write time here. I can write mass here, but not weight. There are differences, very small differences between mass and weight. You will learn about this in physics, okay? And now, for example, one of the famous one is temperature, yes? So if I want to give the information about these quantities, I just specify a number. I don't need to specify a direction for them. But displacement, can you give me a vector quantity? So for example, force is a vector quantity. Because for example, if you see this, I can push this in this direction. It is a little bit resisting. So if I push it in this direction, it will go here. If I put with the same magnitude of force, with the same strength from here, it will go in the other direction. So it means that force not only depends to the strength that I have, the magnitude and the size, it also depends in which direction I am applying the force. The effect would be different. So that is called, so these are vector quantities. The vector quantities are those quantities that can be specified only if I give you the size of that quantity as well as the direction of the application of that quantity. But a scalar quantity is a quantity which is completely specified if I give you just the size of that quantity. Okay? Because especially in physics, we have a lot of vector quantities. Here, at this level, we want to learn about vectors, okay, in general. So mathematically, not from physical point of view. So now we start defining a vector. So you see that in geometry, if I have a line segment, it means that it starts from somewhere, ends somewhere. I can call it, for example, line segment AB. And this is a geometric object. It is not a number. Of course, I can measure the length of this, and I say that, for example, it is 20 centimeters or whatever. But this is a geometric object. This is some shape. It is not a number. But there is no direction assigned to this. It doesn't matter if I say segment AB, line segment AB, or if I say line segment BA. Both of them means this object that you see on the board. But as I told you here, for vectors, it is important that you have a direction as well. Okay? So if I want to represent a vector, so a vector is a line segment again. For example, let us call it CD. But we also assign a direction to it. For example, and how should I show the direction? I show the direction by putting an arrow here. So if I put the arrow here, then this point is called the initial point. And this point is called the final point. So it is important. The one which doesn't include this tip is called the initial. The one which includes this tip of the arrow is called the final point. And then if I want to represent it mathematically, there is a symbol for that. It is very important to write the initial point first. For the line segment, it was irrelevant. It doesn't matter if you want to name it AB or if you want to name it BA, they are completely the same. But when it comes to a vector, because for a vector, the direction is important, so you need to respect the way that you name your vector. You have to write the initial point first and then put the final point. And it is also very important to put this little arrow on top of that. So this is called vector CD. Okay, this is a vector. Okay, and then sometimes, of course, if there is no matter of confusion, we can put a small letter on top of it and say this is vector A, for example. Okay, so we can also show it with the same symbol here. But usually it is better to mention the vector with the initial point and the final point, putting this little arrow on top of that, and respect this that the first one, the initial point should be written first, and the final point should be written as the second place. Okay, and there is also another notion of length. Okay, so the length of this vector is also something clear. You take your ruler and then measure the length of this vector, and then that is a number. That number, it is in your book, it is denoted by this symbol. Yes, so you put them inside two vertical small lines, and this is called the length of the vector CD. Okay, any questions? Is that clear for everyone? So simply a vector is a line segment with an arrow. Arrow shows the direction. Okay, if the initial point and the final point are the same, that is called the zero vector. Okay, so let me write it here. If the zero vector is a vector whose initial and final points are the same. For example, and it is denoted by usually you can use this capital O with an arrow on top of that. This is called the zero vector. So if I ask you what is a vector, if you see something like this, you see that this is a vector. You see this arrow on top of that, so it means that this is a vector. But you realize that the initial point is A, and the final point is also A. So it means that I am facing a vector whose initial and final points coincide. So this means that this is the zero vector. Okay, now if I ask you what is B, what is the answer to this one?
Well, zero.
Again, zero. So it doesn't matter how you name it. As soon as you see that the initial and final points are the same letter, it means that that is the zero vector. So if I ask you what is the length of the zero vector? What is the length of the zero vector? Is equal to, for example, this one, and this is equal to the length of the zero vector. So what is the length of the zero vector? Zero. Zero length unit, yes? So zero length unit. So let me write LU. Whatever unit you choose, zero length unit is the length of the vector. Okay. Now we want to do some operations with vectors. And the first operation I want to teach you is to how multiply a vector by a number. Okay, so we need to do some practical work here together. So let me clean these, we don't need them anymore. So let me give it a title, multiplying a number to a vector. Yes. So these are all of these things that I am writing. I am just talking about are definitions. So there is no why for it. I'm just defining. If I give you a vector and I give you a number, say 2, and I ask you multiply 2 by vector, what you need to do to draw that vector. So let us be a little bit more precise. So for example, assume that this is my vector here. Let me just draw it. So I started from here to here. So assume that this vector here is 3 units, for example. Let me call it vector A. Let me make it 4 units so that we can just calculate everything. So let me be more careful. So 1, 2, 3, and 4. So here, for example. So assume that this is my vector, and then, okay, sorry, I forgot to say something before starting that. Let me just tell you when two vectors are equal. I have to tell you this one first. So let me give this the title, Equality of Vectors. Okay, so this is a little bit intuitive. When do you think it is good to say two vectors are equal? So if you want to say two vectors are equal, what is your expectation about two equal vectors?
They have the same length and direction.
Yeah, that's a more natural one, because a vector is specified by two characteristics.
They have the same direction.
Yes, the same direction and the same length. Yes. So because the vector is something which can be specified by a number, which is its length and the direction. And if you say that two vectors are equal, it means that they have the same lengths and they have the same direction. So it means that they have to be parallel, pointing to the same direction and having the same lengths. Yes, this is the definition of two vectors. So let me write it here for you. Do you have any question, Gustav?
And was that I was going to ask if they were parallel.
Yes, because otherwise, because if I even, for example, if I have vector, for example, 10 centimeters in that direction, and I will take this 10 centimeters again in that direction, I will not be able to say that they are pointing to the same direction because they are not parallel. Okay, so two vectors, A and B. So vector A and vector B are said to be equal if, number one, the length of A is equal to the length of B, but that is not enough. For example, these two vectors assume that they have the same length, but I will not say that they are equal because they are not in the same direction, they are not parallel. So number two, they have to be parallel. Yes, and number three, they have to point to the same direction. They, A and B, point to the same direction. So if these three properties are satisfied for the vectors A and B, then I would say that these two vectors are equal together. And of course, the equality sign is as before. You just put equality sign, yes?
Yeah, doesn't them being parallel just automatically mean that they point in the same direction, or is
No, because it might happen. So this is a little bit tricky. So for example, if I have this line, which is parallel, and then so let me, these two lines, assume that they have the same lengths and they are parallel, but one of them can point in this direction.
Oh.
The other one can point in this direction.
Yeah, okay.
They are not called equal.
Okay.
So I think all of them should be taken care of. So it means that, first of all, the lengths of two vectors have to be equal. They have to be parallel. But of course, in the broad sense, for example, what do I mean? So if I have this line and assume that this vector is here, this vector is here, okay? And then let me clean everything. I consider these two also be parallel. Even though in the very meaning of the word, this is not parallel, they are actually lying on the same line. But let us consider this one as to be parallel as well. So I would say that they are parallel if they don't intersect or they lie on the same line. That is what I mean by being parallel. Either they do not intersect at all, even if I continue them forever, or they lie exactly on the same line. This is what I mean by being parallel. Having the same lengths is completely clear. It means that I measure the length here and I measure the length here, they are equal. And they also point to the same direction after being parallel, okay? So two vectors are said to be equal if they are satisfying all these three conditions. Okay? Now we go back here. So now my point is that I give you a vector, you are supposed to multiply it by a number. Okay, so let me just consider this vector that I have drawn here. And then I ask you to calculate these things for me. So I ask you to draw the vector which represents 2 times a, another vector that represents minus 2 times a, another vector which represents 1 over 2 times a. Yes? So we want to learn how to draw these new vectors. And you see that I have chosen positive 1, negative 1, and a fraction 1. Okay? The drawing is very simple. If I want, let us concentrate here. For example, I want to draw 2a. What I do, I choose a point on plane wherever I want to. For example, I choose this point. And then what I need to do, I need to draw a line which is parallel to my vector. So hopefully I can draw it somehow reasonably good. So I will draw a line which is parallel to that vector. Yes? So any line. Okay? And then what I do, yeah, I have to continue. This is a line. This is the way that you imagine it, okay? It's a little bit hard to draw it. Okay, something like this. So you choose a point, I don't know, from that, it's hopefully you can see. My goal is to draw them in parallel. And then I multiply the length of the vector by this number. What does it mean? For example, I measure the length of my vector. Assume that this is 4 units here. So I know that the length of my vector is 4 length units, whatever it is. And then what I need to do, I multiply this number by that number here, which is 8. Yes? So it means that I have to double the size of my vector. I chose a point here, so I choose 8 units here. So 1, 2, 3, 4, 5, 6, 7, 8. Yes, something like this here. And then it is not finished yet because I need to put the tip of the arrow somewhere, either here or there. This depends to the sign of this number. If the sign is positive, you keep the direction as the previous one. If the sign is negative, you put it the other side. Yes? So for example, here 2a is this vector. And then I can clean the rest of it. This is the vector that we call 2 times a. It is parallel to my vector. The length of it is 2 times larger than the length of the original vector. But because I am multiplying by a positive number, according to this rule, according to this definition, I keep the direction as the original. So for example, here you can immediately tell me what is minus 2a. Minus 2a, I follow exactly the same process before putting it here. What should I do? Instead of putting the tip of the arrow here, I can put the tip of the arrow here. And then it becomes minus 2a. Of course, if you want to, so let me, I don't know what is a good way to do that. So let me change this color here, put the tip of the arrow here, for example. And then let's say that this becomes 2, negative 2a. Negative 2a. If you want to, that's correct. If you want to, for minus 2a, you can go choose another point wherever you like, and then you can draw the minus 2a from there. What is important, that there is no locality for the vectors. It doesn't matter where the vectors are inside the plane or on the, so there is no map. This is not important at all. What is important is the length and the direction. If 2 vectors have the same length and the same direction, then it means that these 2 vectors are equal. It doesn't matter if you draw it here on the board or if you draw this here on the board. They are completely equivalent and equal. Is that clear? So if you multiply by a number, simply multiply the length by that number, The only point that you need to be careful about is that what will happen if the number is positive, keep the direction the same. If the number is negative, change the direction. And then, of course, I don't think we need to explain how to draw this. How should I draw 1/2? Because then I don't want to mess the picture up. So let me start with another point. So assume that this is the point that I choose. What I need to do, I need to draw a line parallel to this. Yes, here. For example, assume that this is parallel. This is a line parallel to my vector. But can you tell me what should be the length? The length here is 4. I want to draw 1/2 times a. So what should I do? The length would be 2. So it means that I choose 2 units, 2 length units here. So 1 and 2. So this would be here. Okay, so this is this point. The length here is half of the length of the original vector. And then what I do, I put the tip of the arrow, which one here or there? Because this one is positive, 1/2 is positive. So I need to respect and keep the direction the same. So what will happen? This becomes this one. So this vector that you see here on the board, I can clean the rest of it, which I don't need. And then I will say that this vector that you see on the board is half of this original vector original vector A. Is that clear? So for example, if I ask you to calculate, to draw the picture for -1/2 A, this is exactly the same thing. Instead of putting the tip of the arrow here, I put the tip of the arrow there. Yes? Okay, so there are some points that I want to ask you. Can you guess what would be the answer to these questions? What happens if I multiply my vector by 1? What do you think will happen? If I have a vector and I multiply it by 1, what will happen?
Nothing.
Nothing means?
Same answer.
It's the same answer, exactly.
Nothing.
Yes, it becomes exactly A itself. Agree. Because 1, it means that I need to multiply the length of my vector by 1, but the length will not change because multiplying any number by 1 will not change anything. And then 1 is positive, so it means that the direction would remain the same as well. So you remember, 1 times A is always equal to A. Now tell me, what do you think will happen if I multiply 0 number by any vector A?
0.
What? Because if you say 0, it's not clear. The 0 means the number 0.
0 vector?
0 vector, yes. Because, yes, that is very important. Because I told you that if I have a vector and if I have a number, when I multiply them, by definition, the answer is supposed to be a vector. On the other hand, you realize that the length of the vector should be 0. On the one hand, the length is 0. On the other hand, it should be a vector. So there is only one way to say that. That is the 0 vector. Okay, now the other way around. If I choose a number, so let us say x is a number, any number that you like, I want to multiply it by the 0 vector. What do you think would be the answer? 5 times 0 vector. What would be the answer?
0 vector.
Again, 0 vector. Very good. So this becomes 0.
0 vector.
Exactly, the 0 vector. So be careful about these 3 rules, okay? You are not allowed to write simply 0. If you write simply 0, people think that that is 0, the number, which means that you don't understand that the answer should be a vector. So these are very clear things. Okay, so let me continue a little bit because I know that you are supposed to practice a little bit on your own. But let me now ask you, let me teach you another topic, which of course I will continue that next time. Now I give you 2 vectors and I ask you to add them. Okay, so this is not something that you can just do it on top of your head, because what we know, what we have learned so far is how to add 2 numbers. If I give you 5 and 6, you can add them, it becomes 11. But now, if I give you 2 vectors, it's a little bit different. What do I mean by adding 2 arrows together? So there is a rule for addition, so I want to define that rule for it. Okay, so let me give this a title here. Adding two vectors. I can write it here. Adding two vectors. Okay, so let me clean this. This might be a little bit tricky sometimes, but let me, for example, let me have this vector here. Let me draw it from here. So let us have it for 1, 2, 3, 4 units, for example. Assume that this is a vector A, and let me have it here. So for example, assume that I have another vector here. Okay, something like this, and I have another vector here, B. Now I want to teach you how to add A to B. So the rule is that if you want to add, sorry, this should have an arrow here. Sure. How should I add A to B? So what I need to do, I need to parallel transport this and draw it from the tip of the second vector. Yes, I want to add A to B. What I do, I take this vector, parallel transport it here. So it means that I am not allowed to change the size. I am not allowed to change the slope. I'm not allowed to change the direction. This is meaning of being parallel transporting. So I will parallel transport this vector from here. So I will try to do that. So it means that I need to move it like this here and draw it here. Hopefully they look parallel, yes? And it was 4 units, so let me make it 4 units from here. And let me change my color here. I have a little bit higher, so 4 units. 1, 2, 3, 4. Okay, so what I did, I took this vector and parallel transported not from the initial point of this vector, from the final point of the second vector. So if this vector is called A, I can safely call this vector A as well, yes? Because I have parallel transported it, it means that the length remained the same, the slope is the same, and the directions are the same. So if this vector is A, this vector is also the same vector. And then what we need to do, I need to connect this initial point to this final point. Okay, so something like this. This initial point to that final point. And then put the arrow here at the final point. This is the definition, okay? So you put the arrow here. This red vector that you see is the vector A plus B. Okay, so this is the way that they have defined that. Intuitively, from a physical point of view, it is good actually. For example, assume that you are sitting in a boat and then actually you are going in this direction if the water is still, but now the water is also going in this direction. Then if you don't start rowing, yes, then what you expect is that the velocity of the boat would be more or less in this direction. Of course, this is intuitively, but you need to know physics to appreciate that this is indeed the case. Or assume that I am exerting a force to this, for example, in this direction, and simultaneously another force to this from that direction. So what you expect from this, you expect somehow that it goes in this direction. Okay, something like this, if you want to understand it intuitively. But for mathematics, you really don't need to care about. This is called the definition of adding A and B. Is that clear? So let me repeat the process. If I have two vectors A and B, I want to add A to B. So what I do, I parallel transport the first one and draw it from the final point of the second one. And then when it is done, I connect these 2 points together. And this you need to remember. Don't put the arrow in the initial point. By definition, you have to put the arrow on the final point. Yes? And this vector that you produce in this way is defined to be A plus B. Is that clear? But what do you think if I do B plus A? So from numbers, what you expect is that there is no difference between 2 plus 3 and 3 plus 2. But of course, these are not numbers, these are vectors. So what do you think? Do you think that the same property still holds? This is called commutativity, yes? Commutativity. Commutativity, yes. Sometimes I have commutativity. It means that you can commute two numbers. For example, if I have 2 plus 3 is equal to 3 plus 2, this means that the addition is commutative. It means that it doesn't matter if I add 2 to 3 or 3 to 2, the answer is the same. Okay? But now, do you think that this would be also the case for adding vectors? Does it matter if I add A to B or B to A? Let us try to convince ourselves that this is actually the case. That is also the case, okay? So why this is the case? If I want to add B to A, what should I do? Yes?
We're adding B to A. All right, so we do the opposite thing. So we start by drawing.
Yes, I have to parallel transport B this time. Yes? So let me parallel transport B and draw it from the tip of this vector. Okay, so what I should do, let me draw it with black. So I need to move this one, parallel transport it here. Yes, so hopefully this would be the parallel to this one. And then I need to separate the length of that one. So what was that? It was 1, 2, 3, and 4, 5. So it would be 1, 2, 3, 4, 5 here. And then this is B. So let me clean what is not necessary here. And then let me fill this. Of course, if you do it with computer, it's much easier than do it with hand. But anyway. So if this is vector B, this is also called vector B because it is parallel. It has the same length and it has the same direction. And then what I told you, do you remember what I told you? I told you that you need to connect these two final points together. So let me draw it with this color. It is, hopefully, it is working here. So let me connect these two. And now tell me, which direction should I put the tip of the arrow, here or there?
There's a B.
Yes, the final point. Yes, everyone agrees at home. So this one. If I can draw it perfectly, very precisely, what is your impression here? These two becomes exactly parallel, having the same length and having the same direction. Of course, I didn't succeed to convince you 100% because it's a little bit tilted here. But you understand that there is no difference between B plus A and A plus B. If you do it using your computer and precisely, this vector, even though this starts with a different point, it doesn't matter at all because the location of the vector is not important at all. What is important is the direction, is the slope, the direction, and the length. As far as these are concerned, they are the same. So remember this fact that addition of vectors is also commutative. It means that you can simply add A to B or B to A. It doesn't matter. They are the same numbers. Let me just teach a little bit more and then I will stop so that you can practice on your own. Okay.
Babak,
Yes, please. Yes?
how would you subtract the vectors?
No, it comes later. That would be on Friday, okay? Subtraction of vectors, I need to define a little bit for you. So, because I haven't finished yet about the adding vectors. So what happens if I have more than 2 vectors I want to add, okay? So let me clean this one. So assume that you have 3 vectors now. So if you don't mind, let me just do the approximations. It would be hard all the time if I want to do this. So assume that you have this vector A, okay? And then you have another vector, for example, this one B. And then you have another vector C. Yes? So let me make it a little bit longer. Now I ask you to draw this vector for me, A plus B plus C. So you need to repeat this process, but with 3 vectors. So what I do, here we learned that it is not important to parallel transport which one. The result is the same. So don't bother about this anymore. So that, okay, I forgot which one I need to parallel transport. It doesn't matter because we realize at least, I hope that I could convince you partially at least, that this is not matter. This is not important. So here, if I want to add these 3 vectors, choose one of these vectors that you like. For example, I choose A, keep it fixed, and then parallel transport the second one from the final point of the first one. So what does it mean? It means that I will take this vector and put it here, yes? So this would be something like this. This would be vector B. So this vector that I have drawn here have the same length, the same direction, and it is parallel to this vector, okay? And then when this parallel transporting is finished, go to the third one and parallel transport it to the last point of the second one. Okay, so it means that I need to take this vector with me and draw it from the last point here. So let me try to do it here. So this parallel, I need to separate the length here. So if I can do it somehow right, this is the length, and I can get rid of this part. So you see, I keep one of them fixed. I parallel transport the second one from the final point of the first one. Then I get some point here. I parallel transport the third one from the last point of the second one. And then you get C. And when all the vectors are done in this way, what you need to do, you need to connect the starting point to the very last final point. Yes? So this would be the vector. And then as I told you here, the tip of the arrow should be at the very final point. So this would be this vector. Okay, so this vector is A plus B plus C. Yes? Let me just draw another. This is a little bit sometimes misleading. What do you think will happen if I have 2 vectors on the same line and I want to add them? So for example, let me have this vector from 5 to 20. So here, assume that this is 3 units. Every 5 I take, okay, oh, sorry. And then assume that another vector I have here from 30 to 50, for example, 4 units. Okay, now if I give you these 2 vectors that are lying on the same line, Let me call this one A. Let me call this one B. Now I ask you to add A and B. So what should I do here?
You just put it back.
Yeah, you just take it back, yes? It doesn't matter if I take this one, draw it from here, or I parallel transport this one and draw it there. Yes, it doesn't matter because the location of the vector is irrelevant for us. So what I do, I just try to parallel transport this here. And you shouldn't get confused if the lines are overlapping. It's not important. So if you are confused, I can draw it a little bit below that. You can see it. Okay, so I start from here, parallel transport, and 1, 2, 3, 4 units here. So this is your B. In principle, this orange line should exactly lie on the same line because otherwise you couldn't see it. This is why I draw it in this way. So if the name of this is B, the name of this one is also B. And then what should I do? For A plus B, I need to connect the initial point to the very final point. Yes. So this means that I take my ruler. Again, everything lies on the same line. I hope that you are not confused. So let me draw it a little bit higher so that you can see everything. So I need to connect it up to here. Where was it? Here. Yes. So from here, the first point, the first initial point to the very final point, and then I put the tip of the arrow on the final point. So I don't know at home, can you see this or not? So this black vector, which in principle should lie exactly on these blue ones and the orange ones. So this whole black vector is A plus B. Yes? Okay, I want to stop here because I want to give you time to practice. There is no exercises in the vector part yet because the order that I'm presenting is a little bit different. So try to practice a little bit on the previous lessons and then we will continue with vectors later. Okay, so I want to end this live stream. Okay, and then I will be back in Zoom and answering your questions if you have any questions on the previous problems. Okay, so we go back to the Zoom. Bye bye.